We're going to derive the derivatives of sine and cosine here, and you may want to review your trigonometry, and if you click on this link it'll bring you to some review videos for the trigonometric functions. So remember how these are defined. Tangent is sine over cosine, secant is 1 over cosine, cosecant is 1 over sine, and cotangent is cosine over sine. And our first important limit is the limit as theta goes to 0 of sine theta over theta. This will help us derive the derivatives of sine and cosine, but it's also an important limit in its own right. So if you take a look at this unit circle here, what you find is that if I draw a ray coming from the origin, making an angle theta with the origin, first of all, at the point where it meets the circle, if I drop it perpendicular to the x-axis, the length of that side is sine of theta, and the length of the arc of the circle opposite the angle is theta, because theta is to the circumference, theta over 2 pi, as the angle is to the angle 2 pi. And also, if you look at this vertical line here, which meets the x-axis at the point where the circle cuts the x-axis, so that's a distance 1 from the origin, then its length is tangent of theta. If you look at this picture, it's easy to believe, and there's a proof given at the end, that sine of theta, the length of this vertical line, is less than the arc on the circle, theta, which is less than tangent of theta, which is this vertical line. And now we're going to use the squeeze theorem to find our limit. So first of all, we're going to divide across by sine theta here. So we have sine of theta over sine theta is less than theta over sine theta, which is less than tangent of theta over sine theta. And of course this means that 1 is less than theta over sine theta, which is less than sine over cosine over sine theta, which is 1 over cosine of theta. If we take the reciprocal of these, then the less than sign switches to a greater than sign, and we have 1 is greater than sine theta over theta, which is greater than cosine of theta. And now taking the limit as theta goes to 0, we get that the limit as theta goes to 0 of cosine theta is less than or equal to the limit as theta goes to 0 of sine theta over theta, which is less than or equal to the limit as theta goes to 0 of 1. And now, because cosine is continuous, this limit is 1, and this limit is 1, and therefore, by the squeeze theorem, this limit is also 1. So therefore, the limit as theta goes to 0 of sine theta over theta is 1.